the same as the rules we use to find normal vulnerabilities, but they can be codified and used systematically. So the static analysis tool can apply those time and time again. The reviewer doesn't need to keep them all in their head. Second, they can tie those breadcrumbs together. So I said a lot of these techniques that insiders are going to use aren't necessarily malicious. There's a malicious use for them, and then there are lots of legitimate uses too. So static analysis can start to look at an entire code base as opposed to however much of it we can cover with manual review, 1%, 3% maybe. It can look at an entire code base and it can track down all these breadcrumbs. And it can start to show you a heat map of the application. It can start to show you where is there a particularly thick line of breadcrumbs. Where do things start to look like, well, there's this suspicious thing and that suspicious thing, and oh, there are 3 of them there. That really warrants some further review. They're not going to find smoking guns, and we'll look at examples of that, because these things aren't smoking guns. They're, again, perfectly legitimate ways to do all the things that an insider would want to do. They're just doing it in an illegitimate way. So just to give you a little idea of what the inside of a static analysis tool looks like, the piece we're talking about is just one aspect of the tool overall. So source code comes in the front end, you build a model from that source code, you run some various kinds of analysis on it, and out the other end come results. The piece that we're talking about changing are the rules. These are the definitions that tell the analyzer what to look for, what constitutes a problem. And here, it's very different from vulnerability detection. Vulnerability detection is useful too. Sometimes an insider leverages something that is technically just vulnerable. This is an example that Matias talked a little bit about earlier, except he just had the first line of code. So the first line of code says, this is PHP code, I'm going to check a request parameter, and if it exists, called IZ, then I'm going to call this getThemeMcommand function. What the hell does getThemeMcommand? I guess it's going to load a theme. If I was doing a manual review and I wasn't looking too carefully at this, I might just read right past it. But the definition of getThemeMcommand is to execute pass-through, which just executes a shell command or a script on the server. So this is a command injection vulnerability, and any static analysis tool worth its price would find this out of the box, because you're taking a request parameter, IZ, and passing it to execute as a shell command. That's just a bad idea, no matter why you're doing it. It doesn't matter that you've got that conditional over to the left that says only do it sometimes. It's always a bad deal. So out of the box rules would find this problem. Some other problems aren't as obvious. They aren't vulnerabilities in and of themselves. So let's talk about a scenario that Matias already showed us code for. A laid-off employee installs code that reads the entire database on a regular basis and sends the results over the network. So there's a couple of bad things going on there, and I'm going to talk about them one by one and then show you from a detection standpoint how we might go about identifying this broader insider threat. So first off, if you're reading the entire database, an entire table, for any reason, it's pretty suspicious. If you're doing migration, that's a possible legitimate use for it, but you probably are looking at more than just one table at a time too. So if you have a query in your code base that does a select star on a single table, that is in and of itself suspicious. It's not a vulnerability all by itself. It's not a command injection like the slide we looked at last, but it's pretty weird. And if you're a manual reviewer looking for insider threats, this is a good place to start. This is a breadcrumb in a pile. Second off, you're reading something from the database, and we'll assume you're in a web app here, because a lot of people looking for these things are in web apps, right? It's your banking site, it's your e-commerce site. These are where insiders tend to target. You're doing manual network connection management. You're opening sockets, particularly sockets with hard-coded ports. Again, perfectly legitimate reasons to do that, but it's pretty uncommon. Why? Not something you'd regularly see in a web application. So we can create another rule that flags uses of sockets in web applications. And in particular, hard-coded socket numbers, just really strange. You're building in some special sauce there. Whether it's for legitimate purposes or malicious purposes remains to be seen. All right, a regular basis. Most applications don't depend on fixed points in time. That's not to say there aren't legitimate reasons why they might, but if you're checking the current time, That's a breadcrumb. That's something interesting. You're not going to do that a million places in your code base. So a manual reviewer looking for insider threats could afford to look at all the places where you read the current time and check on what you do with it. In particular, an interesting thing you might do with it is compare it against some hard-coded value. So if you access the current time, that's a little suspicious. If you access the current time and then compare it to a static string, compile time string in your application, that's really bizarre. There are very few legitimate reasons for that. So again, the pile of breadcrumbs gets a little thicker. I guess that's the last breadcrumb. This is a lot of what goes into the detection techniques that Matias is going to show examples of later. I'll talk about this a little more when we talk about interpreting results. But again, you don't get to find a single smoking gun. You're looking for things that indicate something suspicious. And the more suspicious things you find and the more suspicious each of them is, the more likely you are to have an insider threat. You know, the goal for most organizations would be to run this rule pack against their code base and not find anything. That wouldn't be terribly surprising. You might just not find anything. Or you might find a few of these that are being used legitimately. Or you might find a few more and see, hey, this spot on the heat map is looking a little red. This is actually a problem. Okay, so aside from static analysis, how might you track down insider threats? Your existing functional testing in QA can be pretty useful here. Here, for the most part, you're looking for code that isn't run very often. And probably during a functional test, it's code that's going to look dead, in fact. If you have a mechanism for overlaying what's potentially security relevant, so talking to the database, talking to a directory server, printing content out to the web, executing shell commands, right? There are a handful of things that are security sensitive. If you can overlay your ability to detect dead code during functional testing with things that might be security sensitive, you find people opening sockets in dead code, that's a good thing to get rid of either way. At the very least, it's dead code that might introduce a bug or cause some problem later on, but it's also quite possible that it's behind one of these logic bombs or hard-coded credentials, time bombs, something that's meant to not execute on a regular basis. In production, runtime monitoring can do you some good too, because now this is a little late in the game, but if you suddenly see a bunch of data being written out from your web app that isn't typically, or a bunch of traffic on your admin console that isn't typically there, there are things at runtime that suggest something is out of the normal here. And this comes down to, for the most part, anomaly detection, looking for common behavior and looking for things that deviate from that. So watching your application both in QA and in production can help track these things down. We're particularly partial to the static analysis approach because that's where we've put a lot of our energy, but belt and suspenders does apply here too. Okay. So now you have a really big pile of breadcrumbs. None of them are smoking guns. Let's talk about this code for a second. So you get the current time. That's nasty. You compare the current time against some hard-coded string. That's nasty too. This might legitimately be update code. You might say, we're a startup and once a month we just want to check to make sure there aren't some new bits that we should download. And this was a hacky way kludgy way to introduce that. It's possible. You might be able to talk your way around it, but it might also be nasty. And the fact that we see the two breadcrumbs that we latched onto before, right, accessing the current time and doing a comparison based on it, give us a little more confidence. So in the end, what we can really do with these results is we can associate a strength with them or a priority with them, just like we would other vulnerabilities that we detected in an automated fashion. So some problems, like accessing the current time, might only give us a low fidelity feed that it's an insider threat. There might be lots of reasons you access the current time. But if you compare that with a hard-coded time, that's pretty strange. Maybe that goes at the high end of the bucket. So each one of these breadcrumbs has a strength of implication. How likely is it to describe a real vulnerability? And one of the most exciting things you can do with static analysis is combine these. So you have a low, a medium, and they're all in the same method. Okay, that method definitely warrants manual review. But it's important to see that eventually this does come back to a manual review process. You need a smart person who understands what an insider might go after and how they might do it. And that person needs to take the code base as one input and the feedback from the analysis tools as another input and maybe some runtime monitoring as another input and combine all these things to start looking for the real problems. Of course, if you've been doing this by hand, this is going to sound great because now you've got more inputs. It used to just be the code, right, and figure it out. Now you've got other things to help start to develop that heat map. If, however, you weren't doing it before, if you weren't looking for insider threats, and somebody says, yeah, now you got all these inputs and it's up to you to interpret them, it's going to sound like a hard problem. So a piece of this all boils back down into what's the motivation and what's the organization actually after finding, right? Are they interested in finding these things? If so, this is going to sound like a good story. Okay, so I talked a little bit about how you might find these things. Matias talked about what these things are, classes of insider threats. Now we're going to line the two up and talk a little bit about how latching on to some of these specific attributes at analysis time, we can point out problems at varying degrees of priority.
The face-off. So what have we done? So where are we today? We have 17 insider threat categories and we've implemented them all for Java. 10 minutes. We found multiple real issues in enterprise code. So we have confirmed issues that we found in enterprise code. So the way I'm going to do this is I'm going to rerun the examples and I'm going to describe what we flag. So just to have all up, to have this all up, we have like 17 categories. They are listed here. They are in the slides, so you can, if you want to talk about them afterwards, feel free to do so. So all these categories are like subcategories to these main classes of insider threats. So I will tell you what we flag in the code, what we flag, and how that relates to the code that we've shown before. So first thing first, logic bomb and logic and time bomb. So what we flag is in a low priority, if you get the current time, it goes into the low priority bucket. If you get the current time and you compare it against the, you get the current time and you compare it, it goes in the medium priority bucket. If you get the current time, you compare it and you compare it to a hard-coded date, then we drop it in the high priority bucket. So obviously this was found in the high priority bucket, so it's ticked out, we found it immediately. Backdoors and secret credentials. The way we flag stuff goes as follows. We flag insertions in the database. If you insert something in the credential database, it's a low issue because there are good reasons to insert new credentials in the database. If you insert something in the credential database and it's a hard-coded credential, well, that's pretty suspicious and that's at least a medium issue. If you insert in the credential database a hard-coded credential and you do that at startup, which means that these credentials will always be there and you can always use them, well then it's definitely a high issue. And that's a perfect way to secure yourself access to the machine. What else do we report in this category? We report comparing hard-coded usernames and hard-coded passwords. So all the comparisons of the username with the hard-coded username and or the password with a hard-coded password, we flagged that as a high priority because that's most likely a threat.
How do we tell what a username is?
Okay, so we have a couple of username and password. If the variable is username and password, it's obvious, but not in all applications, username and password. So you can also customize your, we have some custom rules available for your application that you can simply use your variables and we will automatically trigger them. Default command injection in WordPress. So for some cases we do not need any special rules. So the command injection, it will be found by regular static analysis. If you really want to have this in your insider threat code base, what you can do is you can take the command injection rules and port them over to the insider threat rule pack, and we will flag that as a backdoor and secret credential. Nefarious communication, we flag hard-coded ports and sockets. So if you use a socket and if you create a new socket with a hard-coded port, we flag that as a high issue. What we also flag in general is server sockets. In most of our customer base, they are not using any server sockets. So if you do, we flag that as a medium issue. We also flag accessing hard-coded files. So we have a couple of default rules. If you try to access etc password or whatever file you do not want to expose, we're going to flag that. We also have custom rules. So if you know of some files that are really confidential to your organization, you can set them and we can track that. Hard-coded email addresses, so every hard-coded email address is flagged in your application. There are, again, legitimate usages when you want to contact the administrator or whatever. That's a legit usage, but in normal cases, it's illegit.